Hello, this is Bradley Needham. I'm going to do a quick overview of predicates and functors, just so you'll know what they are when you see them in use with the STL algorithms. So first, let's talk about a predicate. Now, a predicate is simply a callable object that returns a Boolean, or true or false, according to some parameter that's passed to it. So an example might be an isOdd function. The isOdd takes an integer as its parameter, and it returns true or false whether the value is odd or not, whether that integer is an odd number or not. And I'm just going to do that with the modulus operator, x modulus 2. If a x happens to be evenly divisible by 2, it will return 0, and 0 of course will be returned as false, and that's because it's an even number. And if it happens to return 1, because it is not evenly divisible by 2, then it will return true from this function. So I might use that simply by, you can see it being called here, if I call the function here isOdd, and I pass the value 4 to it, and L, that should print out false. And sure enough it does, and if I change this to 7, of course it's going to print out true. Now that's a unary predicate. You might also see binary predicates, and binary predicates basically do the same thing in that they return a value true or false, but with two elements or two parameters passed into them. So is equal is an example of a binary predicate. So it takes in two integers in this case and returns whether integer a is equal to integer b. And again, we can see ourselves calling this function this way directly. Is equal 4 and 5, this should be false, and if I say 5 and 5, then that should be true. Now both of these predicates that I created so far are just regular functions, right? They're callable objects, but they're just regular functions. The other thing you can create here, and you'll see used in algorithms, is a functor. And a functor is simply a structure class that overloads the function call operator, or the operator paren. So if I want to change this to a functor, and you still use the same name isOdd, I want to overload operator paren. Well, the only thing that's going to change a little bit is my calling syntax here. If I want to call isOdd, I don't simply call it as isOdd and then pass a value. That's not going to work, because now that this happens to be a struct or a class type, the compiler is thinking that this is a creation of an unnamed temporary, and that creation of that unnamed temporary needs a constructor that takes a single integer as an argument, and there isn't one that exists. So in order to call it the way that I'm doing it here, I would have to say something like isOdd fn, right, to say that my function create a variable called fn, which is of type isOdd, and then I would invoke the paren operator on it, like so. Okay? And that gives me back true, and of course if I pass in 2, then that gives me back false. Okay. Well, now where you'll see that, so let's just look real quickly, just so we can see the difference in algorithms. If I say have a vector of integers, it's my collection 1, and I want to count all of the odd numbers, I can basically use a algorithm called COUNTIF. And COUNTIF takes a range, so collection1.begin to collection1.end, and a predicate. And so this predicate, I'm going to pass it isOdd. Now why did I put the paren here? Well, again, this is a functor. So what I'm actually doing is I'm creating an unnamed temporary of that functor and passing that to COUNTIF, and then COUNTIF is going to internally call that functor using that paren operator. So let's run that. It tells me there's 5 of them that are odd. So 1, 2, 3, 4, and 5. So there's definitely 5 that are odd. So if I did something different and I wanted to do, is even, bool is even, and x will just return not x modulus 2, right? And that should give us ones that are even. So let's go ahead and we'll count. So first off, these are the odd ones, and this one we'll say are even values, and we'll do it by passing is even. And notice this time I am not passing the paren. So this is just so that you can see this when you're using algorithms, the difference between a functor being passed or a function being passed, right? This one's creating an unnamed temporary, which is that functor type, and this one is just passing a raw function here. And I get a success, and I get the odd values and the even values. All right, I hope that helps.